Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in geometric sequences and write their corresponding sequence equations, and how to find a given term for a geometric sequence. How are we learning it? Through the Geometric Sequences Part 2 notes and the Geometric Sequences Part 2 assignment. When can we use this information? To recognize patterns in order to recognize trends in the stock market or housing rates. How do you know you learned it? By getting a score of 4 on the Geometric Sequences Part 2 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, we'll go over the Geometric Sequences Part 2 notes, and then I'll give you time to complete the Geometric Sequences Part 2 assignment on IXL. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Arithmetic and Geometric Sequences Study Guide and any incomplete assignments that you may have. Let's take a look now at the Geometric Sequences Part 2 notes. The notes begin with the learning goals and success criteria. What is a geometric sequence? A geometric sequence is a sequence of numbers in which each term is found by multiplying the same number to the previous term. An example of this would be 2, 4, 8, 16, 32. What you should notice is every time we move from one term to the next, we have a common ratio or a multiple of 2. So we're multiplying 2 times 2 to get 4, 4 times 2 is 8, 8 times 2 is 16, and so on. How can we recognize exponential functions from a table? Well, first of all, the rule is the number of months, my x values, should be changing by a consistent amount, and it should be addition. And my y values should be changing by multiplication. So in this case, we have the months. So this is 1, 2, 3, 4. Well, is there a steady change in the number of months? Yes, there is, and it's changing by 1 month each time. Now here we have 2, 4, 8, 16. There is a steady change, and it is multiplication. We're multiplying by 2 each time. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we're seeing a steady change, and it's multiplication. It is doubling, or multiplying by 2 each month. So therefore, is this exponential? Yes, it is. And if we were to plot these points, it would look something like this and form this curve. So we're given this pattern, 2, 4, 8, 16, and 32. And we want to know what the common ratio is. Well, we already talked about it earlier. Our common ratio is 2, and we found it by dividing this number by this number. So 4 divided by 2 is 2. So that's our common ratio. So what would the next term be? Well, we would take 32 and multiply by 2, and we get 64. So 64 would be our next term. Again, let's look at another example. What is the common ratio? We know that the common ratio is 2. Now, what would the 8th term be? Well, this is the 1, 2, 3, 4, 5 term. So we need to multiply by 2 3 more times. So this is 32 times 2 times 2 times 2. When we multiply that all out, we get 256. So our 8th term would be 256. Now let's talk about the explicit form for a geometric sequence. The explicit form looks like this. AN is equal to A1 times R to the n minus 1 power. AN in this case represents the term we are trying to find. For instance, A7 would be the 7th term in the sequence. R represents the common ratio. N represents the number of the term that we're trying to find. And A1 represents the first term in the sequence. So if we're given a pattern here, 3, 6, 12, 24, 48, we go ahead and fill this in. So AN we don't know. We do know A1, and we do know R. So AN is equal to, the first one is 3, and the R value, we're multiplying by 2 each time, so R is 2. So this becomes 3 times 2 to the n minus 1. Now let's take a look at an example. We have AN is equal to 3 times 2 to the n minus 1, and we want the 5th term. So we're going to take that, and we're going to plug 5 in for n. So this is A5 is equal to 3 times 2 to the 5 minus 1 power. Well, we know that 5 minus 1 is 4. So we have 3 times 2 to the 4th power. Well, 2 to the 4th power is 16. Then we multiply that by 3, and we get 48 is our answer. There's a video here that you can watch on how to check your work when trying to find the common ratio for a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to find the common ratio of a geometric sequence. So we're going to go to symbolab.com, and then we're going to find where it says Geometric Sequence Calculator. And I'm going to click here where it says Common Ratio. And it asks for the sequence. Let's say our sequence is 3 and 9 and then 27. So those are the 3 that we know. I'm going to go ahead and click Go. And it will tell me the equation right here. So it tells me exactly what the equation is. It should be a sub n is equal to 3 times 3 to the n minus 1. And it tells me exactly what my r, or my common ratio, is. My common ratio is 3. So this is how I can use Symbolab to find the common ratio of a geometric sequence. There's a video here that shows you how to check your work when trying to find a given term of a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to check our work when trying to find a given term of a geometric sequence. So we're going to go to symbolab.com, and then we're going to go to the Geometric Sequence Calculator. And then down here, I'm going to go to the one that says Value Given Index. And we're going to enter our sequence. Now, you may have the sequence been given to you as an equation. That's okay, just fine, like the first 2 terms. That's all you really need. So let's say the first term was 4, and the second term was 18. And the term we want is the 7th term. So we just enter our sequence in here and put our index here. Index is the term we want. And we're going to go ahead and click Go. And when we scroll down, it tells us exactly what our ratio is and exactly what our term should be. So our 7th term should be 531,441 over 16. So this would be our solution. So that's how you can use Symbolab to check your work when trying to find a given term of a geometric sequence. Let's talk now about how to access your assignments on IXL using SBLink. So what you'll do is you'll click on the link that takes you to your SBLink, which should look like this, and you're going to log in the same way you would log into your computer. So the first part for your username is going to be the first part of your email address without the @sbcusd.ca.us. So it should be your last name, first initial, middle initial, and then the last 4 of your student ID. Then for your password, it's the same password you use to log into your Chromebook. From there, you'll go ahead and click Sign In. And it should take you to a page that looks kind of like this. You're going to go find the link that says IXL, which is right here. And I'm going to go ahead and click on that link. And it should take me to the IXL login page. So it should look like this. At the top right corner, it should say welcome and then your name. If it does not say your name, then you're not logged in and you won't receive credit for your work. As long as this is good, you can go ahead and close that tab out. And then you can go to your Google Classroom. And then you'll go and find the activity, which is here. And I'm going to click on the IXL link right here. And this will take me to the assignment that I need to complete. So that's how you log into your assignments on IXL using SBLink. Let's take a look now at the Geometric Sequences Part 2 assignment. The assignment begins with the learning goals and success criteria. If you scroll down, there's a link here that'll take you to SBLink. This will allow you to log in so that you can access your IXL activity. Go ahead and log in. And once you've logged in, go ahead and come back to this page and click on this link to go to your IXL activity. And it should take you to a page that looks like this. It says to write an equation to describe the sequence below, use n to represent the position of a term in the sequence where n equals 1 is the first term. Well, we know that an is equal to a1 times the common ratio to the n minus 1 power. So what we should notice is a1 in this case is -7, so that goes here. And then the common ratio, well, we can see that we're multiplying by 2 each time. So my common ratio is 2, so that goes there. And then I hit submit. It tells me I got it right and sends me on to the next one. Well, this one says 4, 8, 16. So I can see that my A1 is 4. That's the first term. And I'm multiplying by 2 each time here as well. So I go ahead and put 2 and hit submit. And notice as I continue to answer questions, my SMART score continues to go up. You're going to continue to work until you get a SMART score of at least 80. If you miss a question, your SMART score will go down. That's okay. Just keep working until you get your SMART score back up. And then when you're done with the assignment, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.